This video goes over two word problems using the greatest common factor and the least common multiple. So our first question is about a jewelry maker who is going to use 24 blue beads and 30 green beads to make necklaces. We want to know what are the possible number of necklaces that can be made if each necklace has the same number of blue beads and the same number of green beads. We also want to know how many beads of each type will be on each necklace once we split them all up. Alright, so these types of problems we need to know, are we using the GCF or the LCM? And so there are a couple of clues that we can go back to help us understand which one of those we should use. So some of the clue words that we look out for are things like the greatest, or things that have to do with grouping, things that deal with factors, or if we have a limited amount of something. If we're going to use the least common multiple, some of the clue words are least. If we are working with schedules, if we have multiples of something. So if we look back through our problem, we're going to pull out some key clues, such as the possible number of necklaces. So that will be grouping. We are also looking at the limited number of items that we have. We only have 24 blue beads and 30 green beads. So we are going to use the GCF to solve this problem. All right, so our first step is we need to list the factors, and I like using a T-chart for this, and we need to label them. That just keeps it very organized and easy to pull the information from. So with our factors, if you think of it like this, if we have one necklace, all 24 blue beads will be on that necklace. So the factors is the even way that you can split up the beads that you have. So if you have, for instance, 3 necklaces, you'll have 8 beads, and so on. So again, when you list out the factors, knowing your multiplication tables is going to be the best thing that you could ever do for yourself. So make sure you're memorizing them. It just makes everything so much easier. Okay, we'll do the same thing for the 30 green beads. So if we had one necklace, all 30 green beads would be on that one necklace. If we had 2 necklaces, we would split up those beads and then we would have 15 on each necklace. So we will do this for all of the factors of 30, because that is how we split up the beads evenly, is by finding out what the factors are. Alright, so after we have all of the factors listed out, then our next step is going to be that we want to circle all of the common factors, because then we know that we can use up all the beads evenly, and the common factors are the possible number of groups or the possible number of necklaces that we can make. So if we look at our common factors, we could have 1, we could make 2, we could do 3, and we could do 6. So those are all of the possible ways. Our greatest common factor, or the greatest number of necklaces that we could make, would be 6. So if the question asked us for the greatest number of factors, or the greatest number of groups, we would say 6. But it's not. It's asking us for all of the possible ways that we can make necklaces, and then how many beads of each color will be on each necklace. So what the question asks you for is important in how you say your answer. Alright, so we're almost done. Our third step is that we need sentence answers. Every word problem has to have a sentence answer. Alright, so one possibility is that she can make 6 necklaces. If we have 6 necklaces and we need to split up those blue beads, we basically have 24 divided by 6. That means that each necklace has 4 blue beads. And if we take our 30 green beads and split them up into 6 necklaces, we will have 5 green beads. So to visualize that, we have our 6 necklaces with our 4 beads on each one. And if you multiply that, we basically have 4 times 6, which is our 24 blue beads. Then we have our 5 green beads on each one. So if you multiply that, or 5, 10, 15, 20, 25, and 30, that gives you the 30 green beads. All right, another possibility is that we could make 3 necklaces. Whoops, not bracelets, necklaces. If we had 3 necklaces, we still need to split up our beads. So 24 blue beads divided onto 3 necklaces gives us our 8 blue beads. 30 divided by 3 will give us 10 green beads. So if we draw that out again, our 3 necklaces with the 8 blue beads and 10 green beads, we will see that we can evenly divide those up and use up all of the beads on all of the necklaces. So sometimes drawing a picture can help you understand what the numbers are. Sometimes you can do it all in your head, which is fine. Another possibility is she can make 2 necklaces. So with the 24 beads split up onto 2 necklaces, there will be 12 blue beads, and 30 divided by 2 will give us 15. All right, and then the last one is that she can make 1 necklace. And if she had 1 necklace, then all of the blue beads, all of the 24 blue beads will be on that 1 necklace, and all of the 30 green beads will be on that 1 necklace. Okay, so these are all of the possibilities that you can do. But again, the greatest number of necklaces would be 6, if that's what the question is asking you for. All right, so that was a lot of work, a lot of writing, a lot of talking. Hopefully you can see how listing it out in an organized way really makes it easy to understand. Okay, our last example is that a science club is ordering caps and shirts for the kids in the club. And we know that there are 45 members in the club. So the caps are going to come in packages of 3, and the shirts will come in packages of 5. So we want to know the least number of packages of each of those that we can buy and still have enough for everyone who's in the club. So again, how do we know if we're using the GCF or the LCM? Oh, wrote that a bunch of times. Okay, so we're going to list out some of our clues. So the clues again for the GCF are words like the greatest, or if we're grouping things, if we have the factors, or if we have a limited amount. Okay. The clues that we're going to use for the LCM are words like least, if we have multiples of something, if we're going to be repeatedly doing something, or if it's like an ongoing thing or an ongoing item. So if we look back at our problem, we can see that, well, first of all, we have the least number of packages. So that is a good clue that we're going to be on the LCM side. We also know that we need more than just 1 package of 3 shirts, or 3 caps and 5 shirts, because we have 45 members. So that's an ongoing thing. We have no limited amounts, and greatest is not in there, so we know that we're using the LCM. All right, here's a quick visual to understand how the multiples work. 1 package of caps has 3 shirts, 2 packages have 6, and 3 have 9, and so on. So you're listing out the multiples, but they're grouped by the packages. If we had our shirts, so we have our 5 shirts that come in 1 package, we're going to get the multiples. We need to multiply that enough times to have enough for everyone in the club. So we're going to group them by package, but we'll end up listing out the multiples. So that is our first step, is to label and list out the multiples. So for the caps, we will have 3, 6, 9, 12, on and on and on until we get to 45, because we need 45 caps for everyone in the club. Okay, but each group, so one package will have 3 caps, 2 packages will have 6, 3 packages will have 9, and so on. So even though you're listing the multiples, it's grouped by how many of that item is in a package. So when we do our shirts, well, shirts come in packages of 5. So we'll list out all of the multiples of 5 up to 45, because we know we need that many for our members. And then we see, okay, how many packages do we need? So again, one package has 5, 2 packages have 10, and we keep doing that to find out how many packages we need all the way up to 45. All right, so after this, our second step is that we basically just need to answer it, but we need to put it into a sentence. So we would say that the science club will need to order, and the way we find this out is we're going to count up how many packages until we get to 45, and that would be 15 packages of caps. Then we count up how many packages of shirts we need to get to 45, and that would be 9 packages of shirts. All right, so thanks for sticking through this whole lesson. It was a lot of words again, a lot of talking, but thank you for watching. Just kidding. There's actually one more example that we have to do. Okay, so this question is, Miss Khatib runs every 3rd day and goes to kickboxing every 5th day. Out of 100 days, we want to know on which days will she do both activities. So when are they going to overlap on the same day? So again, we have a GCF problem or an LCM problem, and we have some clues that will help us know which one to use. For greatest common factor, we have words like the greatest. We're grouping things. We have the factors or the parts of a number, or we have limited amounts. For LCM, we have things like least, the multiples, if it's an ongoing thing, or stuff that has to do with schedules. So let's look back at our problem to see what we can figure out. And we know that we are going to be having some kind of schedule where on the 3rd day and on the 5th day something happens. But we need to keep going with that up to 100. So those are going to be the multiples. It's also an ongoing schedule, and well, it's ongoing and it's a schedule. So all of those things combined tell us that we're going to use the LCM method to solve this problem. Okay, our first step is to list the multiples, and remember, you want to label everything. So the days that I will go running are on the 3rd day, the 6th day, the 9th day, and you keep listing out the multiples. You could go out to 100 or out to about here, and then we can, I'll show you a way to get the rest of the numbers at the end. Okay, so the days we do kickboxing are the 5th day, the 10th day, and you list out all of the multiples of 5, and those are the days that we go kickboxing. Okay, our second step is we need to find the LCM, or the least common multiple, to know which day both activities happen. And that will be on the 15th day, because that's the day I run and do kickboxing on the same day. So as a sentence, we could say that on the 15th day, Miss Khatib does both activities. And we're not done though, because the problem is saying out of 100 days, which days do both activities happen? So the next time it happens is on the 30th day. So we will rewrite our answer to include that. So we'll say that she will do both activities on the 15th day, on the 30th day, and we want to find out when it happens again, all the way up to 100 days. So to help make this clear, we can say the first time is the 15th day. The second time it happens is the 30th day. And the third time it happens, well, if you can see the pattern, once you have the LCM, or the 15th day, you're basically going to be doing both activities every 15 days. You're going to be repeating that pattern. So you could do the math calculations on the side of your sheet if you don't know your math facts up to this point, and that's fine. So if you want to know the fourth time it happens, you're going to multiply the LCM times 4. The fifth time it happens, you'll multiply the LCM times 5. And the sixth time that they both happen, you'll multiply the LCM times 6. And that will give you all of the days that you do both activities up to 100, because that's what the question asks you for. All right, so you don't always have to list out all the multiples to 100. You could just find the least common one and then multiply it out. All right, lastly, we need a sentence answer, but we kind of already did that, so you can check that off. And now you are officially done. Thanks for watching all the way to the end.